What is up sa inyo lahat? Magandang umaga, hapon o gabi. At ito ang ating pinakabagong episode dito sa ating Munikel. So ba't nga pala tayo nakapa-Minecraft, Kuya Munikel? Sabi mo busy ka. So ayun nga, di ba? So ito napaka-espesyal na episode na to at napakaganda ng lugar. So abangan niyo na lang kung ano mangyari dito sa ating Minecraft School. Wow, school! Sige, magkita-kita tayo mamaya. Magkikita pa rin naman tayo mamaya. Abangan niyo na lang, ha? Okay, see you there!
So first, let's talk about what a normal distribution is. A normal distribution is also known as the Gaussian distribution, and it's a probability distribution of a continuous random variable that is symmetric above the mean, showing that the data near the mean are more frequent in occurrence than the data far from the mean. In graph form, we see that the normal distribution will appear as a bell curve called the normal curve. The normal distribution is the most common type of distribution assumed in technical stock market analysis and in other types of statistical analysis. It's very important because it fits many natural phenomena, for example, heights, blood pressure, and IQ scores. The graph of the normal distribution is characterized by two parameters: the mean or average, which is the maximum of the graph and about which the graph is always symmetric. This is represented by the Greek symbol mu, and the standard deviation, represented by a lowercase sigma, which determines the amount of dispersion away from the mean. A small standard deviation produces a steep or narrow graph, whereas a large standard deviation produces a wide or flat graph. This is a unimodal distribution, meaning it only has one clear peak or most frequent value, which is the mean. The value increases at first, rising to a single peak where then they will decrease. The mean, median, and mode of the data coincide at the center of the distribution. The total area under a normal curve is equal to 1 or 100%. Thus, the symmetry implies that the area on either side of the mean is equal to 0.5 or 50%. The curve itself is asymptotic with respect to the x-axis, meaning they do not actually meet or touch. The graph goes on and the area under it gets smaller until it almost looks like the curve is touching the axis. The normal distribution is widely used in understanding distributions of factors in a population and has developed into a standard of reference for many probability problems.
Hi, I'm Alezandra Shanelle and we are going to talk about the mean, median, and mode in a normal distribution. Here's the example of the normal distribution graph. This graph has its mean, median, and mode. Did you know where it is located? Find it in this graph. You're right! The mean, median, and mode is located at the center of the normal distribution graph. In a normal distribution, the mean, median, and mode are all equal because the distribution is symmetrical. The shape of a normal distribution depends on only two values, the mean and the standard deviation. Did you know that the numerical value of mean, median, and mode are just the same in a normal distribution? But it is different in a skewed distribution. And that's all for the mean, median, and mode.
Hi guys, this is Kuya JP or Kuya Munikel, and today we're going to talk about the empirical rule or the 68%, 95%, and 99.7%. So first things first, what is empirical rule? It is a quick estimate of the spread of data in a normal statistical distribution. The rule states that nearly all the data will fall within 3 standard deviation of the mean. 68% of data falls within 1 standard deviation from the mean, 95% within 2 standard deviation, and 99.7% within 3 standard deviation from the mean. To fully understand the empirical rule, first thing you need to know is to have a basic knowledge about standard deviation. Standard deviation shows how closely groups in a set of data are clustered around the average. The smaller value of the standard deviation, the narrower the graph is. The bigger value of the standard deviation, the wider the graph is. So in short, empirical rule is often used in statistics for forecasting, especially when obtaining the actual data is difficult or impossible. So once again, I am Kuya JP or Kuya Munikel. In this lesson, the empirical rule or the 68%, 95%, and 99.7%.
Hello everyone. So now I'm gonna show off two examples of the empirical rule or the 68, 95, 99.7 rule. So I'm gonna give you two kinds of examples here. One is a simple word problem, while the other is a real life scenario. Okay, let us start. So here is a standard normal curve where the mean mu is 0 and the standard deviation is 1. We're looking for the area under the curve that is between -2 and 0. Ready? You can pause the video to answer the given area. Are you done? If your answer is 47.72%, then you are correct. Since the area needed to find is located on one side of the curve, this means that the area we're looking for is less than or equal to 0.50 or 50%. Using the 68, 95, 99.7 rule, we can simply find the area that lies 2 standard deviation away from the mean and divide it by 2. So now I'm gonna show you an example of a real-life scenario that uses the 68, 95, 99.7 rule. Again, pause the video to draw the graph and answer what is needed to find. In a class of 30 students, the teacher discovered that the grade was normally distributed with a mean of 75 and a standard deviation of 5. Find the area above 80. If this is your graph and the area, then you are correct. There are two ways to answer this problem. The first way is to find the area below 80 and subtract it from 1. Using the 68, 95, 99.7 rule, 80 is 1 standard deviation away from the mean. Since the area shown in the graph goes over the mean mu, we're going to divide the area 0.68 by 2, then add 0.50 to compensate from the left side of the curve, leaving us with a sum of 0.84 or 84% below 80. But we're not done yet. We're looking for the area above 80. So we can take the area below the 80 and subtract it from 1 or 100%, leaving us with a difference of 0.16 or 16%. The other way is to simply subtract the 0.34 or 34% from 0.50 or 50%. We got the 0.34 from the 1 standard deviation that we divided by 2, and subtracting it from 0.50 will result in the same 0.16 or 16%.
Let us have a look at another example. So we have a mean of 80 and a standard deviation of 4. And we are looking for the percentage between 72 and 88. But before I explain, I want you to pause this video and try to answer it yourself. Now let us sketch the graph first. As you can see, we have the mean of 80 and 1 standard deviation above the mean means that we should add the standard deviation, which is 4, and that's going to be 84. 1 standard deviation below the mean will be 76 because we subtract 4 from the mean 80. Then 2 standard deviations above will be 88 and below will be 72. And 3 standard deviations above will be 92 and 3 standard deviations below will be 68. Again, we're looking for the percentage between 72 and 88.
As you can see from the graph, here is 72 and here is 88. And we are looking for the shaded part here. Both 72 and 88 is 2 standard deviations below and above respectively from the mean. And from the empirical rule, 2 standard deviations away from the mean has a percentage of 95. So there we have our answer. The percentage between 72 and 88 is 95%. Did you get the same answer? Now, taking a more realistic problem. In this example, we're looking at the heights of women that is in a normal distribution. It has a mean of 165 centimeters and a standard deviation of 6 centimeters. And it looks like we want to know what is the percentage of women whose height is between 159 and 177 centimeters. I want you to pause this video and challenge yourself to answer this one. Again, let us sketch the graph first. So we have a mean of 165 and one standard deviation away would be 159 and 171. 2 standard deviations away from the mean would be 153 and 177. Then 3 standard deviations away would be 147 and 183. 159 is located here, and we know 1 standard deviation away from the mean would give us 68% based on the empirical rule. So by dividing this, we'll get the value from 165 and 159, which will be 34%. Now, to get the value from 165 to 177 centimeters, we know that this part, which is 2 standard deviations away from the mean, gives us the percentage of 95. So by dividing this by 2, we would get 47.5%. Now that we have the value that are covered from 159 to 165 and 165 to 177, we would just add it up to get our percentage, which leads us to 81.5%. Therefore, the percentage of women between 159 centimeters and 177 centimeters is 81.5%. Did you get the right answer?
So ayan mga kaibigan, maraming salamat sa panonood ng ating video ngayon. Sana may natutunan din kayo kahit hindi to Minecraft. Alam ko namang hindi nyo to pinanood ng buo dahil hindi nga to Minecraft. Pero yun nga, maraming salamat sa paniniwala ng ating clickbait. At ako yung humingi ng pas. Uy, si Sly! Oh, andito si Sly. Grabe talaga oh. Sly the Miner, and isa sa mga idol ko po yan. Kaya mag-subscribe din kayo kay Sly the Miner. At nandito siya ngayon sa ating server. Ay, hindi ko pala ito server. Server Tony Wetsky na inyong kakaabangan, ang PMNS. Kaya maraming salamat sa panonood. At ako muli si Munikel, and nagpapasalamat sa inyong pagtangkilik ng ating video. Don't forget to subscribe and hit the like button. Share nyo na rin sa mga kaibigan nyo ha. Kaya thank you so much and bye-bye.